Hello everyone, our journey continues with working with numbers into a second set of examples where I'll be dealing with some math, intelligence. Let's say you're going to sale and you are given a number like this, 3.142 pi. That's what most people say as the value of pi. And you are told to find the ceiling of this. The technical meaning of ceiling is to say the next integer that is greater than this value. If that is the task given to you in Excel, you can do that easily using the ceil function. But Python also has the ceil function, but you don't see it in the native format. So you need to import this knowledge that is native within Python. But if you do not put the import maths there, you won't be able to do this. So I have imported maths for virtually all of the new set of examples, and I'll just show you how to demonstrate that. So once I do import maths, the knowledge of doing this in maths is going to be invoked. And when you come into your task, what you want to do is to say x dot, x is here. Sorry, it's going to be maths dot ceiling. No, this is not capital M. It is math dot ceil, and I'll pass in my value. My value in this case is x. When I do that and I return this, I know what the result should be. The result should be the next integer higher than this should be 4. We're not rounding. We are doing the next integer higher than 3.142. So your result should be 4, not 3. Okay, so you can see result is 4. It works pretty smoothly. The reverse is when you go to floor. Floor technically means the next integer lower than the decimal number that has been given to you. We are focusing on the integer, and in that case I'll say math.floor, and I'll pass my number to it. When I run this, I expect the result to be 3. Let me clear the result screen. When you run this program, you should get 3 as your result, and that is indeed what we see down here. Floor gives you the next integer lower than the decimal number given to you. Ceil gives you the next integer higher than the decimal number given to you. If you were given a right angle triangle with a side A, you can change this to AB. Let's say one side is 4 meters, the other one, side B, is 3 meters, and you are asked to find the hypotenuse. You can invoke your Pythagoras theorem here to do square root of a square plus b square, and that will be the square root of 16 plus 9. That will be square root of 25, which will give you 5. But rather than go through all of that, why don't you just write math.hypot, and then you pass the two variables there. You have a comma b, and Python will apply that to your math knowledge to do the computation and keep the results in here, and then it displays the result to you. So it tells me square root of 25 eventually is 5, and that is awesome. You need to know this, and you can practice this as many times as you want. Next demonstration has to do with finding the minimum or maximum of a series of numbers that might be given to you. So in this case, I have a list of numbers. I just randomly typed some numbers there, and if you want to find the minimum, you can type min of that number series, which is x. And when you execute this, the result should be 1, because 1 is the least in that series. But if you are interested in the maximum, you can put it like this. In fact, we can go as far as saying max result is this, min result is minimum of x, and we can come back into our result and say max is max result, min is equal to min result. So we won't have to overwrite anything. And when you indicate this, you run this, you get max is 10, min is 1. It's a very powerful way of finding the greatest number in a series or the least number in the series. Just look at the series name, and without even importing maths, Python can solve that for you using the max and min function. When you get to POY, you need the math knowledge to be imported. We have two numbers here, number which has a value of 2 and the index which has a value of 3. The task is to raise 2 to the power of 3. How do I go about doing that? Remember previously we could say number asterisk asterisk index. This is the traditional way of doing it. This works and there is nothing wrong with it. But the second method I want to show you is that you could have just done something neater by doing math.power. And this is asking you, where is the number? I'll say my variable number is here. And it's asking me, which index do you want to raise it to? I say I've created that variable as an index. And when I say 2 raised to power 3, I expect the result of 8. Let me clear the output screen here. I run this and I get 8, which is correct. That is awesome. So when next you want to do something very exciting, raising one number to another number, to the power of another number, consider using math.power. Now, let's quickly go to round. Round is a little bit funny. It's not something you do importing math knowledge. You don't need that. Python can give that to you natively. But where I said round is a bit funny is because many people get confused when they are rounding numbers. So let's show some of their confusion. You have 3.142 as the number that has been given to you. So typically if you do round, the number is x. And if I say to 0 decimal place, when you run this, you get this. It's giving you, one major number is what you have in there. If I go in here and I say 2 and I run the result, you can see that it gives me 3.14. If I go in there, let's say this one, I change it to that number is actually a very long number. So let's say import maths. And then somewhere down here, I say x is math.py. Yeah. So if I say, give me that to 6 decimal places, sort of, and you run this, it gives me 3.141593. You have that degree of freedom here. But what if I say, okay, how about you just make this -1? What do you get? 0. What if I make this 1? What do you get? 3.1. So you can play around with the index that you have in here and you'll be able to round your number as much as possible. The reason why the -1 gave you 0 is because I only have one digit here. If, for instance, I put 1, 2, 3, 4.5, 6, 7, 8, 9 here, and you come in here and put x -1, what you will get is not going to be the same. Rather, what you see is that it goes in front of the decimal point and it knocks the next number out. It knocks it out, and that's why the result here is 1230. If I put 2 here, it knocks 3 also off, so I'll get 1200. And then it goes on and on like that. Play around with round and you will enjoy working with it. Next demo is square root. You need to be able to do square root of any number given to you, whether it's a perfect square or not. But in this example, we're working with a perfect square. We have imported maths, and I'll come in here and say, I need maths.sqrt. That gives me the ability to find the square root of any given number that is here. And when I run this, I'll get my result as 4. So let's say someone has given you something that is not a perfect square, like 34. 34, square root of 34 will be closer to 6. So we're expecting something like 5.89 something here. Yeah, correct. So you don't have to get a perfect square as your number before you invoke the square root, function. It works in a very brilliant way. The second to the last, I'm jumping some prod because it requires a little bit of explanation. So let me use truncate as the next demo. When you get to truncate, I'm coming back to my pi and we're saying truncate math.trunc. If I truncate x, sorry, it should be bracket. If I truncate x, anything after decimal goes away and it gives me just the substantive integer, which in this case is 3. That's the simplest way of demonstrating math.trunc, which truncates the decimal part of your number. Now we'll come back to SumProd. SumProd is beautiful. It's extremely powerful. Excel also has this. It's a way of saying if I give you multiple series, in this case we are having 2, and I ask you to do 2 times 3 plus 3 times 4 plus 4 times 5, I need the result of it. In Excel, you can do it, but for most people, they will first do 2 times 3, keep the result somewhere. That should be 6. Okay, so let's do it manually. That's 6 plus 4 times 3 is 12 plus 4 times 5 is 20. And then they will get the result as, this is 1838. So this is 38. This is what the result should be. But why should I go through that approach when I can say math.sumprod and it will ask me for the series that I have in mind, and I'll say there's an X series and there is a Y series. I need you to do the maths and then give me the result. Store the result here and I need you to display it. If I run this, I get my 38, which is exactly what we had in mind. It's an extremely powerful feature in Python. Play around with some of that. You can go as far as saying, okay, maybe you put a Z in here and then this is going to be a list. Maybe you just put some random numbers like 5, 6, 7. I have no doubt in my mind that if you run this and if this function is capable of taking multiple entries, you will get the correct result. It says, oh, I can only practice for 2, and that's the only reason why this isn't going to work. So you go back and keep your series to 2 and SumProd will always work for you. So in this video, we've been able to demonstrate to us how to do sum product of 2 series of numbers given to us. We learned how to do square root of any number, whether it's a perfect square or an imperfect square. We learned how to, round numbers to certain number of decimal places or some significant numbers. We learned how to raise a number to a certain index using math.pow. We were able to find the maximum and the minimum in any given data series. We were able to find the hypotenuse of any given right angle triangle using the math.hypot method. And we were able to find the floor, which is the integer lower, the next integer lower than the decimal number you are given. And we were able to find ceil, which is the next integer higher than any decimal number you are given. These are exciting techniques in maths that you can, equip yourself with. You never can tell when you will need them. I hope you find this very useful. If yes, click on like, give me your comment, recommend the channel to your friends. I see you in the next video. Thanks a lot. Bye for now.